Hello class. Today we're going to use our knowledge of long division and what we've learned so far about polynomials to divide two polynomials in the real numbers. Remember, a polynomial is defined as an expression that represents the sum of several terms that contain different powers of the same variable. You know them to come in the form ax squared plus bx plus c. Let's start with a straightforward example, simply dividing two real numbers using long division. Here we're going to divide 124 by the number 5. "24" is our quotient, 124 is our dividend, 5 is the divisor, and 4 is our remainder. In general, the dividend, which is the number that you're dividing, is equal to the quotient times the divisor plus the remainder. It's always a good idea to check your work, so let's make sure our numbers do follow this formula. 124 does indeed equal 5 times 24 plus 4. Let's look at a more challenging problem involving polynomials. For our next example, we're going to look at the problem divide 4x cubed plus x minus 6 by x squared minus 3. Two polynomials with obviously different degrees of x. Now, just as a quick aside, we're going to include the values 0 for placeholders just so we don't get confused. As you can see in the divisor, we have x squared plus 0x minus 3, and we'll do the same in the dividend. In order to determine our quotient, we're just going to look at what we multiply our divisor by to get the first term inside of the dividend, just like we would with a normal long division problem using two real numbers. And so we see that 4x becomes our quotient, and we are left with the 13x minus 6 as our remainder. And that concludes our discussion on using long division to divide two polynomials. As you saw, it's very similar to using long division to divide two real numbers. However, we have the slight challenge of coming up with a little bit more intricate quotient and remainder. So I hope you enjoyed watching and learned a little something. Until next time.